right, here we go into single and double replacement reactions. So just to review from our textbook here, in a single replacement reaction, a single element replaces another element of a compound. So two substances as reactants, an element and an ionic compound, and then we've got a single switcheroo. So the single element must be more reactive than the element in the compound because it's able to swap, right? And so we read last week about chemists being able to have their chart of how much reactivity they have. And copper is more reactive than silver. So in this demonstration that I've got for you, we're using copper sulfate. Okay. Then down here we get a double replacement reaction. In double replacement reactions, the two compounds exchange elements, and most of these occur in an aqueous solution, okay? So, our aqueous solutions here have been prepared for us by Mr. Claus, and don't you just feel more scientific holding a flask like this with cool colored things in them? So, we're looking at single replacement, one swap, and a double replacement, a double switcheroo. So this picture here shows us what happens if we were to take copper wire and put it into silver nitrate, okay? So the product is you get silver and then copper nitrate. We're dealing with copper sulfate. So even though they're both blue, we're going to see something different happen in our reaction, but it is still very cool. So, what is happening here is this takes a lot of time. So I took another time-lapse video of this whole process, and so I'm going to describe to you what took place in that video, and then I'm going to show you the results. So, we take this copper sulfate, and we put some into a test tube, right? So we put some into each test tube, and then in one test tube, which I labeled Fe, and if you remember from our other reaction, that's iron, right? So in that one, we put steel wool again. We put steel wool, and you guys remember what steel wool looks like. Well, as a result, look at what we've got. So this is after probably 10 minutes of setting there. And the longer that it sits, or the more steel wool that I would put into it, the blue color will actually begin to turn more olive green, because what's happening is that the steel, let me move this way, the steel is actually getting copper coated. So the liquid copper in this solution is actually those copper ions are like grabbing hold of the steel wool fibers and coating it. So the copper is actually part of our switch, and it is resulting in that coppery color. And so the longer it sits, the less of the blue color you'll see, because the copper is going away, well, transferring onto the steel wool. Our other test tube is potassium iodide. And the first time I read this, I thought it was Cl, but it's Ci. So we've got potassium, and then we've got iodine. All right, so potassium iodide, the solution looks like this, just nice and clear. So with a dropper, I'm taking a clear solution, I'm putting it a few drops, like 3 drops, into the test tube of copper, and look at what we got. We got ourselves a pretty precipitate. It kind of looks like snot. Maybe like it's kind of, it has some volume to it where it like floats on there. You see that? Like it's like how do I get this to focus? Like if it clings to it. Let me get in front of that light. Everything is backwards. This is why I can't curl my hair. Okay, so it's definitely got kind of a gelatinous feel to it, and it just sits up there. So you got a cool precipitate out of it. Add something clear to something blue, and you get yellowish stuff. Okay, so that is the demonstration. And now let's look at what happened on a chemical level. Okay, so first off, I want you to think, which of these was a single replacement? Which was a double replacement? What do you think? Single replacement versus a double replacement. Okay, so now let's look at what happened chemically. So, our first one with our steel wool. We have our steel wool, our iron, plus copper sulfate, which replaced in such a way that we were left with copper, because our copper now coated the steel wool, right? And then the iron sulfate. So what do you think? Was that a single or a double replacement? How many swaps did we have take place? Okay. Then on our other one, we've got potassium iodide plus copper sulfate again, resulting in copper iodide, that's our floater, and potassium sulfate. What do you think? Single or double replacement, okay? So you're going to be answering that in the Google form. And then you're just going to be thinking about how could I predict this if I didn't have copper sulfate and potassium iodide just chilling in my cupboard at home? If I had just given you a formula, if all I gave you was this, and I said, hey guys, single replacement or double replacement? Or if I just gave you this, I said, single replacement or double replacement? Well, you could say, well, I can kind of tell how much stuff swapped. What if that was covered up? What if I only showed you the reactants? What if there we go, let's do that. What if I only showed you reactants? Could you look at the reactants alone without any knowledge of the products and say, I know that one's going to be a single replacement and that one's going to be a double replacement? How could you figure that out based on this alone? That's your final question for this lesson, all right? All right, I've got some cool stuff to dispose of properly now. Have fun doing your lesson.